Hardware implementation. In previous works, the authors have developed strategies of hardware processing in the areas of filtering and compression. The first approach presented the wavelet transform architecture and decomposing process for denoising of electroencephalographic, e.g., signals, Gauna and Ballesteros, 2005. The second, it presented the comparison in hardware implementation between Fur and Air, Corridor and Pedraza, 2009. The last project organized the above results in the architecture for biomedical compression based on discrete wavelet transform, DWT, and run length encoding, Ballesteros et al., 2010. The discrete wavelet transform is composed by two stages, the convolution of the input signal by the wavelet base and the subsampling process. The convolution is performed by the equations. And? In the above equations, Y1 and Y2 are the outputs of the Fur filters, high is the impulse response of the low-pass filter, E is the impulse response of the high-pass filter and X is the input, signal. The expression corresponds to the delay in the input. The value of M depends of the length of the wavelet base. For example, if the base is Sim6, then M is equal to 12. The subsampling is calculated, according to implement the equations, 9, 2, 12, we propose the following blocks. Architecture of discrete wavelet transform. Bank of register, this block stores in an M position register the samples X in an orderly way, depending of its arrival time. At the output it showed the current input value and the last N1 inputs. If the reset signal is active, all the outputs are set to 0. Coefficients block, 2 M positions memories keep the value of the wavelet filters, high and G. Control unit, it generates the control signal to select high or G. Because the subsampling process eliminates the half of operations, it is most efficient to calculate only the half of operations, it means every 2 cycles of clock. Multiplier, adder, it computes the mathematics operations of the equations, 9, 10, and 11, 12. In figure 12, M corresponds to the length of the Fur filter, cell is the bit of selection between the low-pass or high-pass filter and res is the number of bits of every input data. To complete the compression model, 2 stages are added to the previous one, the thresholding and the encoding. Thresholding block, a comparison between a threshold value and the data from the low-pass or high-pass filter is doing. It computes the hard rule and the data with a lower value than the threshold are modified to 0. Encoding block, it performs the run length method. At the output of this block there are 2 signals that go to a memory. The first signal indicates the position in the memory where the second signal ought to be stored. And we present the RTL of the multiplier/adder for 8 coefficients, M equals 8. The 8 multipliers and 7 adders were modeled. RTL, multiplier/adder block. N, the RTL of the thresholding stage is presented. The comparator is the main structure of the thresholding block is. Its input is the output of the multiplier/adder block. RTL, thresholding block. The architecture was modeled in a FPGA Spartan 3XE3S200. It obtained the following performance. Performance,